Hi guys. In this video, I want to talk you through an example of using Kirchhoff's junction rule, and I also want to simultaneously introduce you to complex circuits. Complex. So what we've been looking so far at is two bulbs, one right after another. We call that in series because they're on the same path, one after another, or in parallel because they're like side by side. But you could also have some combination of them. So right here, I have one resistor in series with these two, which are in parallel. So one resistor in series with two in parallel. Um, and for this problem, I want you to, so this is a complex circuit. See if you can solve for this stuff. I'm going to call this one resistor 1, 2, and 3. See if you can solve for this stuff. Try to write Kirchhoff's loop rule for this circuit and Kirchhoff's junction rule for this circuit. The useful ones, the useful equations. So take a minute, pause the video, try that. And I'm going to solve it out over here. I'm going to start off with the loop rule. So this one is Vt. This one is V1. This is V2. And then this is V3. So the loop rule is going to be plus Vt minus V1 minus V2. And that's equal to 0. And what I'm trying to solve for is V1. I'm actually given V2 in this one. So V1 is actually just Vt minus V2. And I know Vt is 9 volts and V2 is 1.8. So that's 7.2 volts. Check. And now, so what is, so I got V2, given V2 actually, and then V1. If you want to solve for V3, do you know how to do it? You could write another loop rule equation, or I can say, like, starting from here, I know if I go in a loop, V3 is going to be equal to V2. And in fact, parallel branches of a circuit are always going to have the same voltage difference across them. Because you can see, like, just using the loop rule again, this loop would be identical to this loop, except for these branches. But those total equations are the same. So if they're the same, then that implies, like, by the transitive property or whatever, that this branch would be equal to that branch. If that doesn't make sense, basically just Vt minus V1 minus V3 is equal to 0. Combining those equations, V3 has to be equal to V2. Getting back to the current, so applying the junction rule, I see that the current through resistor 1, I1, is what's going into this junction, and what's leaving is I2 and I3. So I1 is equal to I2 plus I3. Now, do I know what I1, I2, or I3 are? Not right now. How do I find it? Do you see it? Yeah, good idea. Use Ohm's law. So I'm going to start with this one, V2. I know the voltage across it. V2 is equal to I2 times R2. And the voltage is 1.8 and the resistance is 10. So I2 is 1.8 volts divided by 10 ohms, and that is equal to 0.18 amps. And similarly, I can do the same thing with V1. V1 is equal to I1 times R1. The current then is going to be the voltage, which I solved for over here, 7.2 volts, divided by 20 ohms. And what does that get me? 0.36 amps. Cool. So what is I total? I actually know that I total, the current coming out of the battery, is actually equal to V1. So I total is equal to 0.36, I2 is 0.18, and actually the thing to solve for is I3. So I can use this equation to solve for I3, and so plugging that in, I3 is equal to I1 minus I2. That's I1 minus I2, so 0.36 minus 0.18, and that's also 0.18. I say also because, hey, look, the resistances are equal, so when the current is sort of splitting, it's not going to favor one or the other. It's going to be symmetrical. So that's another way I could have arrived at this. I could have solved for this, notice these are equal, and just divided by 2. Cool, so that's example 1. And now example 2 is not one resistor in series with two in parallel, but one resistor, this one by itself, and it's in parallel. It's on its own branch in parallel with these two resistors that are in series. Take a minute, again, pause the video, see if you can solve for the voltages and stuff that I had up here. I'm going to call this one resistor 1. This one, bottom one is 2. This one is 3. See if you can write out Kirchhoff's loop rule and junction rule for this circuit. Take a minute, pause the video, try it out. Do it. I see you need to do it. Do it. Okay, so the junction rule, sorry, loop rule first. So Vt minus V1 minus V2 equals 0. And also Vt minus V3 equals 0. So if actually just automatically, I know if Vt is 9 volts, then V3 is equal to 9 volts. So that's a 0, and that's nothing. That's also just Vt minus V3 is equal to 0. So V3 is also 9 volts. And what do I know? I know these two together add up to 9 volts. If I move this over. And I'm given, actually, I cleverly placed this voltmeter here. I can solve for V2 right here. That's a 2. By rearranging this, I know that V2, it's the 9 volts minus the 6.58. V2 is equal to 9 volts minus 6.58. I'm skipping a step. I'm just rewriting this. V2 is equal to Vt minus V1. So 9 volts minus V1, 6.58. And that is 3.42. 3.42 volts. 2. And now the currents. So the junction rule here is I total is equal to I1 plus I3. If I knew I total or I3, then I could solve for I1. Actually, I basically have all the information I need. If you were to, I don't have space here, but if you were to write that VIR chart, you'd see you have enough to solve for what you need. I'm gonna go with starting with V3. I know V3 is 9 volts, so I3 is gonna be V over R, which is V3 over R3. That's a V. V3 over R3, and that is 9 volts over 10 ohms, which is 0.9. Forgive me with the units. And so this is I total. I'm going to solve for I total last. I want to solve for I1. So I1, I know that the voltage across it, oh, I can't do this one in my head. I1, the voltage across it is this, and the resistance is that, so I can use I1 is equal to V1 over R1. I1 So that is 6.58 over, oh man, my head's getting in the way, 30. And doing that in my head, I see that the current is 0.219 amps. And now how do I get the total? I add these two together because that's this branch. I total coming in, I1 going out, I3 going out. So if I add those two together, I get 0.1119. How did I mess up? Whoops. Plus 0.9. Yeah, 0.119 amps. So I did I1, I3, I total, and now I2. How do you relate I2 to this? Well, there's no split along this branch, so I1 is actually equal to I2. So this right here is equal to I2. And there we have it. That is applying the loop rule and the junction rule to solve for stuff on a simple circuit and for a complex circuit. This was a complex circuit. Hope that was helpful. Take care.